Now we are going to discuss about frequency modulation. What is frequency modulation? Frequency modulation means whenever the carrier signal frequency will be varied in accordance with the message signal, that is called frequency modulation. So for that modulation, what we need? At first we need a signal generator, that is baseband signal generator, which have the two parameters, that is frequency and amplitude. Okay, so for the by varying this, now we can vary the message signal or baseband signal frequency, and we can vary the amplitude of the signal, baseband signal amplitude, by varying this knob. Okay, now we are going to see what kind of message signal we are getting. Look, as this is connected in channel 1 and yellow signal is the channel 1, so that is the message signal. And what is the frequency of it? That is 966 Hertz of baseband signal frequency. Okay, and that amplitude is given, that is 400 or 416 millivolt. Okay, and for the carrier signal, what you need to do, just without connecting this message signal to the modulator, and that modulator is XR2206, that is the modulator IC which can generate a carrier signal by itself. Okay, so how it can be generated? Look at this. If we don't connect the baseband signal to the modulator, we get the carrier frequency directly from here. As this is channel 2, okay, this is channel 2 connected at this end, and the blue signal is the carrier signal. What is the frequency of it? Look at this. This is the carrier signal, and the frequency is around 45 or 46 kilohertz. Okay, so now we are going to modulate the baseband signal. How we can do it? Just connect the message signal to the modulator. Okay, and we are getting here the modulated signal. Look at this. We can clearly see that whenever the baseband signal amplitude is higher, then the frequency is very much higher, and whenever the baseband signal amplitude is lower, and then the carrier signal frequency is lower, and it can be elaborated like this. Look at this. It can be clearly visible, right? So look at this. For this case, as time period is greater for regarding to this time periods, so time period greater means frequency is lower, and for this case frequency is higher, right? So from there we can get two different kind of frequencies. One is frequency lower frequency or FL, and this is higher frequency or F, or you can say F min, and this is called F max. And from there we can get the frequency deviation of the signal, right? And then that is the frequency modulated signal, and then we can vary the amplitude to check what kind of difference is being going by varying the amplitude of the baseband signal. Look at this. This is maximum amplitude. If we decreasing the amplitude of the baseband signal, look at this, the deviation will be decreasing. That means higher frequency and lower minimum frequency and maximum frequency are almost looks like same, right? So that means we have to get the optimum value to give the maximum amplitude. Okay, now we are going to demodulate the signal. So now look at the demodulator connection. What is there? Look at this. From this end we get the modulator output, and then we have to connect it to the demodulator right here. Okay, and that is IC LM565 or VCO IC. Okay, sometimes 565 will not be there, then you can use 566 also be there. Okay, so there are two types of VCO ICs are there, that is 565 or 566. Okay, so here we use that 565 IC, that is giving us the demodulated output. Look at this. Just connect it and we get the this kind of demodulated output. Okay, so this is frequency modulation. Got this? If we change the amplitude of the signal, look at this, what kind of differences are there.